let's compare properties of functions. So 3 bits of review. Let's do 3. Let's not forget that functions are us looking for patterns. We're trying to find patterns and use patterns to then rationalize or mathematically apply to real-world situations. Functions themselves, functions can come in 4 different versions. We can see them as equations. We can see them as graphs. We can see them as tables. And we can also finally see them in words. Those are our 4 versions of functions that we understand. Let's talk about what the word properties means. So we want the properties of functions. So what I've written is 2 functions here that we could compare. Now just a reminder, when we write functions out, we can also rewrite functions as the linear equations that they represent. So I'm going to do that right now. So let's take this version right here, turn this into y equals 3x minus 4. And then the other one, let's rewrite that one as y equals 1/3 x plus 15. Now, when we're comparing properties of functions, what we're looking at is we are comparing the slopes. We are also capable of comparing the y-intercepts. Now, we have no context with these equations, so what we're looking at now is just purely the slope and purely the y-intercept. If I look at these 2 slopes, what I know from those 2 is that this one is steeper than this one. This one is more level because it's only rising 1 and then going 3, rising 1 and then going 3. When I look at the y-intercepts, I know this one's going to start below the origin, and this one's going to start way above the origin. Those are the properties we're going to look at, but what we're going to look at is we're going to look at them in the context of a real-world problem. All right, so let's get to that real-world problem. So we have a certain car has a gas mileage of 22 miles per gallon, and the gas mileage of a certain sport utility vehicle is represented by the function shown. Okay, here's the twist with these. They're going to give us the functions in 2 versions, words, graph. There are 2 functions here. The first one is a car that gets 22 miles per gallon. So let's write the equation for that. We're going to say y equals 22x. But let's not leave that just sitting out there. Let's make sure that we know what that is. That is the car. And then we have the table here. So that's our sport utility vehicle. So let's put SUV or SVV or SUU or who knows. I'm going with SUV. It's just a really sharp U. And we don't have an equation for this, but we do have some points here. So let's use our slope formula. Let me switch over to purple for this. I'm going to use 0.1 and 0.2. So I've got 38 minus 19 over 2 minus 1, which is going to give me a slope of 19 over 1. So then my SUV is y equals 19x. Now, what are we here to do? We are here to compare properties. The final question is, compare their gas mileage. So what we know from what we see here is that the car is going to get 3 more miles per gallon of gas than the SUV will. So what we could say is the car has better gas mileage by 3 miles per gallon. That's how we compare those 2 functions. We look to see what's the difference between those 2 gas mileages. In this problem, then, the slope of these was the miles per gallon that each vehicle got. All right, let's take that and make it into a bigger problem, or find a bigger problem. Let's look at this one here. I've got Peppermint Butler. That's Peppermint Butler. And tree trunks. That's tree trunks, not SUV. tree trunks. Each have a monthly cell phone bill. Peppermint Butler's bill is represented with the function y equals, so let's get Peppermint Butler here. Peppermint Butler, y equals 0.15x plus 49 bucks, where x is the number of minutes, so x equals minutes, and y is the total bill. Total bill. And then we've got tree trunks over here, and we don't have tree trunks yet, but our first thing we're going to do here is let's just compare the y-intercepts. All right, the y-intercept here is 60, so we don't know the equation yet for tree trunks, but we do know the y-intercept is 60. So tree trunks' line hits the y-axis at 60. So if we look at that, let's go back and look and see what we've got here. Peppermint Butler's bill starts with a $49 charge. Tree Trunk's bill starts with a $60 charge. What we can interpret from that comparison is that Peppermint Butler pays a smaller monthly fee. We could even articulate it that Peppermint Butler's spending $11 less a month. Okay, so that's what our y-intercepts mean in this situation. Let's then look at the slopes. So our slopes then, I don't know why I erased that, so I've got x is minutes, y is total. So let me put my y back, equals 0.15. And here's my tree trunks line here. All right, so now we're going to compare another property, and that's the slopes. Let's look at the slopes. We don't have the slope for tree trunks, so we've got to figure it out. Let's go back to our slope formula. So I've got x sub 1, y sub 1, x sub 2, y sub 2. Now let's do the math. I've got 72 minus 60 over 120 minus 0. 72 over 60 over 120 minus 0. That's going to give me 12 over 120, which is equal to 1/10. That's 1/10 of a dollar. So instead of me writing 1/10 the fraction here, let me write 1/10 the decimal, 0.1x. Now put the 0 in there just for fun so we know that it's a dime. Hello, it's money we're talking about here. So now we have a slope for each of these, and as we compare the slopes, we can see that tree trunks pays less per minute. Not only can we say that tree trunks pays less per minute, but we can also say that it's a nickel per minute. When we look at this, it's 5 cents less per minute. All right, let's do one more comparison now. All right, what does this say here? Let me erase tree trunks for a second here. Let me erase this piece. Who pays more for 200 minutes? Well, now we're going to check to see who pays more for 200 minutes. So just so that we remember, this was our equation for tree trunks. This is our equation for Peppermint Butler. Like if we lose that, we're in trouble. It's going to be really difficult to keep these straight if we don't have that information. So let's see. Let's do Peppermint Butler first. I've got 0.15 times 200 plus 49. All right, some side math. 200 times 0.15, 0010, 0002, 0003, and I've got two spots. So Peppermint Butler is spending y equals 30 plus 49, y equals 79 bucks. Peppermint Butler is forking over $79 for 200 minutes. Let's look at tree trunks now. So I've got y equals 0.1 times 200 plus 60. Y equals, well, 1/10 of 200 is 20 plus 60. Y equals 80. Let's make sure we know that's tree trunks there. So tree trunks spends $80 for 200 minutes. And if we're comparing the properties of those things, what we know is for 200 minutes, that Peppermint Butler is spending $1 less. Now, I have a feeling that that's going to change, that Peppermint Butler will be spending more than Tree Trunks if Peppermint Butler uses the phone more than that. All right, let's get to our wrap-up. Let's look at the wrap-up here in the review of what we're doing. Let's not forget the 4 things that functions can be. Functions can show up as a graph, a table, in words, or an equation. If we have these, we've got to turn them into an equation for us to be able to compare them. When we are comparing the properties of functions, we're looking at the y-intercept and the slope and maybe a specific value. And I think that's it. Yeah. When we have those 2 functions, you know what, let's put this on here because this is important. Give yourself the chance to be right about these. Label. Label, 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 because then you're going to know what's what when you look at your paper when you're done. Good luck with that labeling.